Hello, everyone. Today, we will learn how to configure the additional access parameters for industrial robots. We will cover the following topics in today's lesson. By the end of this lesson, I hope that you will be able to configure additional access parameters in RoboGuide, including understanding the logic and methods of parameter settings. We will explain these concepts through practical operations. Let's begin Task 1, configuring additional access parameters. First, open RoboGuide. Next, click on New Cell to create a new workspace. In the subsequent creation wizard, there are a total of 9 steps. Step 1. Process selection. Choose Handling Pro and click Next. Step 2. Work cell name. If we do not need to change the name, we can directly click Next. Step 3. Robot creation method. Select the default option and click Next. Step 4. Robot software version. Choose the latest version and click Next. Step 5. Robot application tool. Select Set EOAT later and click Next. Step 6. Group 1 robot model. Locate the model with the order number H721 selected and click Next. Step 7. Additional motion groups. We do not need to add anything here, so click Next. Step 8. Robot option. Here, we need to add the additional access motion components. First, in the software option, select Sort by Order Number. Check J518, Extended Access Control, and click Next. Finally, click Finish to complete the creation. During the creation process, when prompted to select the flange type, choose Standard Flange. On the Touchscreen keyboard, press 1, then press Enter to continue the creation process. After completing the project creation, the next step is to configure the additional access. In the top menu, go to Robot, select Restart Controller, and choose Controlled Start. After entering the Controlled Start interface, move the cursor to Extended Access Control and press F4, Menu. Since we only have one robot, we select one, Group 1. Next, we need to specify which access number corresponds to the additional access of the robot. The robot already has 6 axes, so the additional axis starts from number 7. We select 7 here and press Enter. The next options are 1. Display or modify additional axis. 2. Add additional axis. 3. Delete additional axis. Since we are now in the process of creating an additional axis, we select 2 and press Enter. Next, it will ask how many additional axes we want to add. For this example, let's add 1 additional axis. We then enter the configuration mode, where we select an ENS method by choosing 2 and pressing Enter. Next, we need to specify the size and type of the motor. Select 62. After entering it, press Enter. Following that, we need to choose the type of motor and its maximum current control value. We select 2, AIS 8 and 4000 with 80 amps. Next, we need to choose the movement type of the additional axis. Select Linear Axis by choosing 1 and pressing Enter. For the direction of travel of the additional axis, we use the Y-axis as an example, so we select 2 and press Enter. Next, we are prompted to set the gear ratio. Here, we enter 10. There is an English explanation. In the case of a linear axis, the value we enter represents the distance the axis moves when the motor rotates one full turn. In the case of a rotary axis, it represents the number of motor revolutions required for the additional axis to rotate one full turn. After entering the value, we press enter. The next step is to set the maximum speed of the additional axis. If we do not make any modifications, the default speed value will be 666.667 millimeters per second. For the sake of illustration, let's modify it. We select 1. Change the speed to 1000 millimeters per second, and then press enter to complete the setting. Next is the direction of the motor. If we select 1, the positive rotation direction of the motor is set as the positive direction. If we select 2, the positive rotation direction of the motor is set as the negative direction. We select 2 here and click OK. Next, we need to set the upper limit position of the additional axis. Enter 3000 and press enter. Then, enter the lower limit value. Input 0 and press enter. Next, set the origin position. Enter 0 and press enter. For the first acceleration and deceleration time constant of the additional axis, we will not make any modifications. Select 2 and press enter. Similarly, we will not modify the second acceleration and deceleration time constant. Select 2 and press enter. We will also leave the minimum acceleration and deceleration time constant unchanged. Select 2 and press enter. The next step is to select the load inertia ratio, which has a corresponding formula. Here, we will directly enter 3 and press enter. Next, we need to set the servo amplifier number. We select 2 and press enter. Next is the type of servo amplifier. We choose 2 and press enter. Next is the brake number. If we enter 0, it indicates that the additional axis does not have a brake. If we enter 1, it means that the brake line of the additional axis motor is connected to the servo amplifier of axis 6. If we enter 2, it represents using a separate brake unit, with the brake line of the additional axis motor connected to port C of the brake unit. If we enter 3, it represents using a separate brake unit, with the brake line of the additional axis motor connected to port D of the brake unit. Here, we enter 1. After entering the number, we press enter. Next is the setting for the servo timeout. Here, we need to enable it, so we select 1 and press enter. Then we set the servo shutdown time. We set it to the maximum value of 30 seconds and press enter. Once we have completed all the parameter settings, we will return to the initial interface. Next, select 4 to exit the settings interface and press enter. Then press 0 and press enter to select exit. Next, click the FCGN button. Select Start Code and press enter to restart the robot. This completes the parameter configuration for the additional axis. In this lesson, we have learned how to configure additional axis parameters in RoboGuide. Through hands-on practice, we have mastered the steps and logic of parameter settings. More importantly, through this case, we have realized that configuring parameters for industrial robots is a task that requires a high sense of responsibility. I hope that in your future studies and work, you will always maintain a scientific spirit and a rigorous attitude, and contribute to the development of industrial automation.